Shiny for Python is a fantastic framework to build web apps with Python. And no, even though Shiny originated in the R data science world, PyShiny doesn't have anything to do with that. It's just that the ideas and concepts are similar, but under the hood it's all Python and R isn't used. Of course, there is already a super powerful framework to build web apps with Python, and that is Streamlit. So in today's video I want to show you 4 features of PyShiny that Streamlit users can also appreciate or are even going to love. And just to be clear, this isn't a drop Streamlit and only use PyShiny kind of video. This is more like, hey, check out these cool features, maybe you want to try them at some point. So with that said, let's dive in. One of the first things that pops up when you talk to Streamlit users is that they love Streamlit for its rapid prototyping approach. So today we're going to build this little Shiny app to see how fast we can work with this, or to check out if we can do rapid prototyping with Shiny as well. This app isn't too fancy, it just has a drop-down menu that you can use to filter a data set. The table and the plot is filtered accordingly, and if you click on the table, you'll see that a specific penguin is highlighted. So a penguin is highlighted because this data set is about penguins. Just in case I haven't said this, we're filtering for penguin species here. So let's try to build this. Inside my IDE, I still have this app open here and I can still use it. I can filter stuff or click on things. And then we also have already a script filled with all the imports and all the data that we're going to use. So if we execute all of this, we can check out the penguins data set and see that this is how our data looks. It isn't too important for this video, but just so that you have seen the data, that's how it is. So now if we look at our app, we need to first get a drop-down menu. To create such a drop-down menu, we're going to use the UI module and use the input select function. All of the inputs in Shiny start with input underscore, and then we just have to assign an ID for this input and the title for the input that we also see here inside of our app later on. Now all of the inputs have this kind of structure: first ID, then name, and then we specify specific things for this input, where for a select input, for a drop down like this, we want to specify the choices, which is just a list of things that we extract from our data. And we also want to specify what we currently have selected, which is ATHLYTICZ, which is one of the penguin species in here. And we've already seen inside of our app that we will calculate this data set here based on our input of the data or of the penguin species that was selected. So we already know that we're going to need to calculate something based on this input. In Shiny, this is called a reactive calculation. That is just a function that you decorate with this reactive calc decorator. And in the best case, you also use type annotation to let the code know what kind of output it will generate from this calculation. And then it's just a function that returns what you want, in this case, a data frame. So we're going to take our polars data frame, which we loaded originally, and then we're going to filter this based on the species column being equal to the species input that we specified earlier. And there you see how the ID connects to what we need later on, namely all inputs can then be reached with input.species followed by parentheses to actually fetch the value. So you actually have to make a function call. So now that we have code for an input and for the data set that will be displayed later on, we actually need the code to display stuff somewhere. First, we notice that we have a 2-column layout here. So let's add this. We can do so using the UI layout columns function, where we specify the widths of the columns that we want to have, and then we specify the things that we want to stick into the columns. And here we can say that, okay, we want from the UI module, we want to get a card. These things here that you see here, they are called cards inside of the Shiny framework. So let's say that our card has a specific width and it has a specific header. This is the one we have seen here. And then to actually create an output for this table, what we need to do is to render the table, to render the data frame. And for that, there is another decorator inside of Shiny. It's called @render.dataframe, and then we specify another function that we can call arbitrarily, but I like to call it meaningfully. So in this case, I call it penguins table, and we return a rendered data grid of the data set that we have created earlier on. You know, this reactive calculation here. And for this second card, we can do the exact same thing. Let's also throw in a second card here, and let's call it penguin scatter plot. So now that we have this code, let's actually load this app. Right now, I'm still displaying the final app here. So let's go into our terminal and use the Shiny run function to load the app that is in recording.py. This is the file we're currently working on. And I also want to set the reload flag so that when I save my file, things are reloaded. And now we can click on the link here, ask it to display everything in the viewer panel. And now we see that our app is in here. Right now, it's pretty much what we have seen before, but right now the table doesn't do anything and we don't have a plot inside of the right card. So let's change this. All we have to do is to create another render function. In this case, it uses the decorator @render.plot because we want to have a plot output, and we specify a function with a meaningful name once again. And there we get the data by fetching the data using these parentheses from the reactive calculation that we defined earlier. And then we create a plot using a helper function that I have created for this. It is imported here. Don't worry about the specific of this. It's just creating a plot from a data set, a selected row, which we currently set to none, and an input species. So if we save this now, we can see here that our app immediately updates and we have a plot output now. Interestingly, this also works without the return statement later on, but just for consistency, let's use a return statement here as well. Now we said that we wanted to click on stuff and then highlight a specific penguin inside of the plot. So let's do that. For that, we have to set the selection mode of our data grid to row, and then we can create something similar to reactive calculation, but it's actually called a reactive value because it's not automatically calculated. So let's create such a reactive value and initialize it with none. And then we can replace the none that we have here with the reactive value. It also has to be called to fetch the actual value. And now if you save this, you see that everything still renders fine, but nothing actually is happening. We now have to create an interaction for the click event here. What we do now is we create a reactive effect using a function that we don't necessarily have to name. So it's common to just call it underscore. And then we have to check what cell was selected inside of this table here. Actually, let me throw in a comma in here so that it's formatted nicely, but this only works once we completed the code here. So let's just stick in hello in here. So now everything formats nicely again. So we see here that the selection mode was row, and inside of this table, we want to get this selected row. So what we do here is we check in with the output that we have specified earlier. We check in with the cell selection, check whether the rows exist. And if they do, we do something. And in the other case, we do something else. And in this case, when the rows exist, we select our reactive value to what we can fetch from this selected row, and in the other case we just do none. And now if we save this and click on stuff, we see that our plot updates immediately. So with that, we quickly built an app, and I know it wasn't that quick in this video because I've been explaining all the steps in between because I want you to also understand what's going on. But in principle, this doesn't take a lot of effort. It's just 50 lines of code for an app that does something nice like filtering a data set and then displaying a plot that can also change based on clicks on a table. So that tells us that with Shiny, it's also possible to do rapid prototyping. And the main reason why this is so rapid is because we're using this kind of syntax that Shiny allows using this with statement, where we just throw in the things that we want to calculate. And mostly all of the user interface stuff is thrown for us. But there is actually a second way of creating Shiny apps, which I think is a nice feature. So that's feature number 2. And that's this splitting of UI and logic. You see in this script here, I've recreated the exact same app, but instead I've used the so-called core syntax, which first lays out the user interface using placeholders. You will find familiar things like the input, but you'll also find familiar things like the layout columns, UI card. But there, where we want to calculate stuff, there is just an output placeholder. And the same thing is true for the output placeholder for plot. And then we have a separate function that takes inputs, outputs, and session, and is usually called server. And in there, we have our reactive calculation, our renderings, and our reactive effects. So this is just a different way of writing the exact same app, but I personally like this because it helps you to separate concerns, basically. You can start out with fleshing out the user interface, where should things go, and then later on, you write the code logic to actually fill the placeholders. In my opinion, this express mode of working with Shiny apps apps is all fun and games when it's just a small app, but when I want to build a huge app with lots of different parts, it helps me to write the user interface before and then write the server logic later on. That's kind of my approach, but it's perfectly valid to only use the express mode of working with it. By the way, if you've enjoyed this video so far, I'd appreciate it if you hit the like button. This helps me to know if you actually like this content, and also it gives the algorithm a little nudge to let it also know that you enjoy this kind of content. So thanks for hitting the like button, and now let's get back to the video. Another thing that Shiny brings you is best described when we look at something that Streamlit would do. For example, here I've created a similar app with Streamlit. The only thing I did differently is that you cannot really click on the tables, but instead have to select the row that you want to highlight and then the plot updates. But with some extensions, you can also get this table click feeling inside of Streamlit. I just didn't feel like building this here because it didn't come out of the box with Streamlit. Also, we have a filter here. So basically it's the exact same app, but one thing that I changed was that I also added a timestamp into this app here that's called last calculated, and it shows us that this stuff was updated here at this exact point in time. Now, if I change the output or like change the species that is selected, then we see that the timestamp changes. And also if I click on a different row, I want to have row 21, we always see that this timestamp updates immediately. And the reason why this happens is because fundamentally Streamlit apps try to execute everything for this app, basically the whole script from top to bottom, recalculating everything. I know there are ways to cache stuff and so on to keep information, but in principle, out of the box, this is the behavior of Streamlit. This is also what makes Streamlit so nice and easy to learn, because it's just a regular script that's always executed from top to bottom. Not giving it any shade here, just mentioning it. It's how Streamlit works, and Shiny works a little bit differently, and this is the feature number 3 that I want to highlight, namely Shiny's reactive. You see here I've created a similar Shiny app that also has this timestamp last calculated, and now as I click on stuff inside of this table here, then the plot updates, you can see that things are highlighted in red, but this timestamp always stays the same. That's fundamentally how Shiny differs from Streamlit. Things are not always calculated top to bottom and everything is re-executed. Instead, only the thing that needs to be re-executed is actually re-executed. In this case, if I click on my row here, then only this plot is updated, but this timestamp isn't affected by this at all. Now I have made sure that when I select the different species, that this last calculated timestamp is updated as well. Let's check it out. We have 1039 here, and now if we have Gen 2 as a species, then we have 1040 as a time here. So there you see that when this card updated, then also this timestamp updated. And this happened because I have tied this timestamp to this table, but I don't necessarily have to do that. I could also keep them completely separate to make sure that this timestamp is only calculated at one point in time. Doesn't necessarily make sense here, but if you want, you could do that. And to find out how we do this, let's build this thing. Basically, what we need to do is to restart our recording. I mean, the app that we're doing in this recording.py script. I'm hoping I'm still recording, otherwise this will be all for nothing and I have to redo everything. So if I save this file now, let's do data 1, 2, 3. We see that things don't update yet, and that's because I'm still in the wrong viewer. Let's reopen this in the viewer pane, and now we see that we are actually in the right app. So let's take out this 1, 2, 3 here, and now things are back where we started. Now what I wanted to do is to create a text output above the penguins table. So this is where we create the table. Let's add render to create an output there. And this time we want to create a text output. So we'll use a render text decorator, and let's call this timestamp. And then we want to make this dependent on the filtered penguins data set. So let's just use it in here. And then we can get the current time by using datetime now and then applying some formatting. And this is then what we return inside of an f string. And in order for this to work, we actually have to import this thing. So let's do from datetime import datetime. And now if we save this, we see that we have a last calculated in here. So really that's all we had to change. And now as I click on stuff, we have the exact behavior we did have before. This timestamp doesn't update at all, but as I update my filter data, this timestamp updates here. So we have 10:44:31 here, and now we have 10:44:36 here. And this updates because we have a dependency on this filter data set. If I were to remove this part here, we see now that this timestamp is still calculated because we're still doing this render text timestamp. But now as I change a different species or click on something, everything stays the same because this part of the code has no reason to update once it is finished calculating. There is nothing it depends on. And this is what Shiny does. It creates a reactive graph of all inputs, outputs, and intermediate variables like these reactive calculations. And it checks out how are these things like connected. And once it knows that, it knows when one thing changes, what is the minimum amount of things that needs to change inside of this graph of connected things. And this is a super powerful concept, and it allows you to do a whole lot of stuff without recalculating everything inside of your app, but it can also come with some ramp up time to get, I'd say, fluent with Shiny. You see, the moment you introduce this reactiveness, you also move away from a script that is executed from top to bottom to something that doesn't do that. And you could easily see this by these kind of reactive effect things here, for example. This is something, or it's just like the selected row that doesn't need to be at this exact spot inside of the script because it isn't tied to any output. It's just inside of the script so that Shiny knows there is some input and output and reactive effects I need to take into account. But other than that, it doesn't need to be at this exact position. For example, I could just throw this in here, completely outside of my with UI layout thing, and it just works. You see, when I didn't throw this in here, the IDE complained that something is missing, selected row is never defined, but once I reinsert it at some other place, then the IDE is fine. It doesn't highlight this as an error anymore. And more importantly, as I save this now, you see that my app just recalculated and everything worked just like before. This is also the exact same reason why you can separate out your UI code and your server logic into two separate parts. You can also have it in two separate files, because at the end of the day, Shiny does its thing of sticking this thing together and then figuring out what are the connections. So again, immensely powerful thing, which is why I like Shiny so much, because it allows you to not worry about what needs to be cached, what will be saved as an intermediate variable. Shiny does all of that for you. But again, it comes with the trade-off of having to get adjusted to not just a simple script being run from top to bottom, but also getting used to this part of the code potentially being executed after this or before this or in other kind of steps. That's something you will have to get used to. And this brings me to my fourth and final thing that I think Shiny brings to the tables that other frameworks don't necessarily do, and that is the option to tweak the layout as we see fit. This is kind of a gateway drug to web development because it takes you deeper into the world of web development, of figuring out how to align stuff, how to make things look well, how to use HTML, CSS, and potentially JavaScript. But it's also kind of cool that you have the option to tweak everything. For example, let's add a button to this card header here. So we already know we have our card header Penguins data in here. And now what we want to do is we also want to add a button in there. From Shiny, there is input action button. It is an input, so it needs an ID. Let's call it button. And let's call the label of this button click me. And then let's re-execute this. And we now see that, okay, the button is in there and then can click on it. But right now nothing is happening. Let's not worry about this for now. Let's rather worry about, okay, how do we make this pretty? Right now it kind of looks like a mess. And this is where HTML and CSS and a framework called Bootstrap comes in, because this Bootstrap allows you to customize the design of your web app by using just regular CSS styles or custom Bootstrap classes that will help you make things look pretty. I know it sounds pretty complex. Let's just see it in action. For example, we can stick all of this into a UI.div. This will create a div container, which is something from the web development world. Basically in HTML, you assemble everything into div containers. And that's why nothing really changed right now, because this div container is just a container to hold things. But what we can do now is we can add classes to this div container, and the Bootstrap framework that is also used inside of Shiny allows you to use classes that modify the look of your app. For example, there is the flex CSS class that makes it possible to use display flex in CSS. Don't worry about this detail if you don't know what it is, but if you execute this now, you see that the penguin's data, it moved up to the top, so the display kind of changed now, but this didn't really help us because we wanted to have the button somewhere else, somewhere nicer. So that's why we used the justify content between class, and this will align things at the start and end of the line that we're currently on. And there are some other classes that we can use. For example, we can add a CSS class to this action button. Maybe we should have started with that to make things simpler to grasp. For example, there is the button SM class for making a small button, and you see immediately the button was made smaller. We could also make it into a success button, which is colored to feel like success. In this case, it's green. And now things are starting to look nicer, but this penguin's data, it is still aligned at the top, and I'd like to have it aligned in the middle. I'd like to have it centered vertically. So what we do is we stick this thing here into a UI div container. Again, just a placeholder to put in stuff, nothing really changed, but on this container we can add classes again, and here's where we say the margin on the y-axis should be filled automatically, which centers everything, and that's because inside of this flex display these auto margins work wonders and you can then center stuff really easily. But now we notice that this card header doesn't have the same height as the other card header, which might feel not nice. Again, it's a tiny thing, but I'm just trying to highlight here that you can make really tiny layout and UI changes with Shiny if you want to. This is also a really bad rabbit hole you can go down in, so try to avoid worrying too much about the layout and the look of things before you figured out the logic and the app itself, but just know that you can potentially change the layout if you want, or the styling or the look. In any case, for this second card, let's modify it so that it has some specific height. So let's stick this into a div container as well. And now instead of using a class, there is no specific class for the specific height we want. Instead, let us use add style. And there we can stick in CSS styling like height and set this to 30 pixels. And now we see that the lines of the headers align properly. Let's also throw in a comma here so that my formatter will align this a little bit nicer. But now we see that we once again, we have a non-centered title here. So let's add a class again. Let's do add class, do my auto, and this didn't change a thing because this has to be done inside of a container that has display flex. So we do UI div, stick this in here. So far nothing changed again, but the moment I add the flex display class again, we should be able to have styling or to have centering. And this didn't work, of course, because I have to apply the styling of the height to the container and not to the title itself. And now things work out nicely. So there we have a nicely styled card with a button in the header. We could make things even nicer if we wanted to. We could also throw in a shadow class to have a slight shadow behind this. Could also make it large. I believe shadow LG will make the shadow behind it even stronger, but yeah, I don't think that's necessary. And then of course we also need to tie an effect to this click. Here I'm just doing add reactive effect. It is supposed to listen to a specific event, namely reactive event, and in this case the event that is input button. And then we just do something to display a notification, and for that there is UI notification show, and we just do hooray. And now as I click on this, we see that a notification pops up. So with that, we've covered 4 cool things that Shiny will do for you. Let me know in the comments which one was your favorite, and also let me know what kind of Shiny concepts you want to learn more about, because I have been going through this pretty quickly just to highlight the cool features. It isn't a full-fledged tutorial to show you every step of the way. Let me know in the comments if you want to see more of a tutorial kind of style, and also if you do, make sure to subscribe to this channel so that you will be notified when I create more such tutorials. And now with all of that said, I say thank you for watching, and I will see you next time.